Hey there, Psych 370 students, and welcome to one last video lecture for week 4. This one contains part 2 of my coverage of variables that influence classical conditioning, and what I'm basically going to be talking about in this video is how classical conditioning can be affected by an animal's previous experience with the CS and the US. And so, to explain how prior experience can affect classical conditioning, I'm going to be describing 3 interesting phenomena: latent inhibition, the blocking effect, and sensory preconditioning. Okay, first, latent inhibition, which is also known as the CS pre-exposure effect. Guys, the basic phenomenon here is that if an animal has been repeatedly exposed to a neutral stimulus all by itself without an unconditioned stimulus following it, then when that stimulus is later paired with a US, it takes the animal longer to acquire a conditioned response to it. In other words, it takes more pairings with the US to convert that neutral stimulus into a conditioned stimulus than it otherwise would have taken without the previous exposures. For example, what you're seeing in the diagram here is a dog who's been given many previous presentations of a metronome without food. Then the metronome is paired with food, but despite those pairings, it doesn't learn to salivate in response to the metronome. Now, what you're not seeing here is that the same number of metronome plus food pairings would have been sufficient to elicit a conditioned salivation response to the metronome if that initial pre-exposure phase had been omitted. So in experiments like this, you'd have another group of dogs who go through this same middle phase, this same acquisition procedure that you're seeing here, but they don't get the pre-exposure phase. And unlike this dog, who got the pre-exposure, those control group dogs would learn to salivate in response to the metronome. They would acquire that conditioned response. So that's the idea behind latent inhibition, or the CS pre-exposure effect. Basically, pre-exposure to a stimulus can interfere with, it can inhibit an animal's later ability to acquire a conditioned response to that stimulus. Now, this phenomenon might sound counterintuitive because it would seem like the more familiar you are with something, the easier it should be for you to learn about that thing, right? The effect, of course, suggests the opposite. According to the CS pre-exposure effect, novel stimuli can become conditioned stimuli more readily than familiar ones do. So let me give you a more human example here of this latent inhibition CS pre-exposure effect phenomenon that might make it a bit more intuitive for you. So for the sake of this example, let's say that two people, we'll call them Peter and Lois, have recently started dating. And the first few times they went out, Peter had a few drinks and they both had a nice, pleasant time. But recently, Peter has continued to drink on his dates with Lois, and he's also had a tendency recently to get angry with Lois and be abusive toward her. And let's say that Lois hasn't been able to figure out why Peter has been treating her this way. But a friend of hers, we'll call him Glenn, has accompanied Peter and Lois on their last few nights out, and he thinks he knows why Peter has been acting this way. He thinks it's the alcohol. So Lois doesn't blame Peter's abusive behavior on the alcohol because she had that previous exposure, right, on their first few dates where Peter's drinking, that's the CS, was not followed by the abuse, which is the US in this example. But Glenn does blame the abuse on the drinking because he didn't get that pre-exposure. He hasn't seen Peter drinking around Lois without also seeing Peter being abusive toward Lois, so he's quicker to associate Peter's drinking with Peter's abusive behavior. In other words, we might say that Lois's failure to form that association between the drinking and the abuse was due to this latent inhibition phenomenon, or what we also call the CS pre-exposure effect. Okay, so there's a more real life kind of example about how being previously exposed to a stimulus can inhibit our ability to associate that stimulus later on with something else. Now, to tell you about another way that our previous experiences can interfere with classical conditioning, I need to explain a classic experiment by a psychologist named Leon Kamen. Like the risk Orla experiment that I told you about earlier, the subjects in this Cayman experiment were also rats, and the unconditioned stimulus in this experiment was electric shock. There were two groups of rats. The experiment involved several phases. I'll tell you about the control group first. Guys, the first time these rats experienced the shock, the first time they received that US, it came after they had experienced a compound stimulus consisting of a light and a tone. So in the control group, those rats got this compound stimulus, a light and a tone, presented simultaneously, and then they got the shock, they got the US. When Kamen tested those rats by presenting either the light all by itself or the tone all by itself, he found that they would display a conditioned response to both stimuli. So when they saw the light or when they heard the tone, they froze, suggesting that they had associated both the light and the tone with shock. Okay, so that was the key result in the control group. For those rats, the presentation of either stimulus, the light or the tone, caused them to anticipate and prepare for an upcoming shock. Now, the procedure for the experimental group was almost exactly the same, except they went through an extra phase first. Before those rats ever experienced that light plus tone compound stimulus, they first experienced pairings where the tone, and only the tone, was followed by shock. And naturally, of course, they did acquire a conditioned response to the tone. They froze whenever they heard the tone. Now, after that phase, the rats in this experimental group were treated exactly the same as the rats in the control group had been. So they experienced exactly the same number of pairings of that light plus tone compound with the shock. However, when Kamen tested those rats, he found that they still froze when they heard the tone, but they did not freeze when they saw the light. So they still associated the tone with shock. They still expected the shock to occur after the tone occurred, but they didn't act like they had learned any association between the light and the shock. And remember, these rats had experienced the same number of trials where they saw the light and then got the shock. The light and the shock occurred together for them just as frequently as they had for the rats in the control group. And yet, unlike the rats in the control group, the ones in this experimental group failed to acquire a conditioned response to the light. Now, guys, this phenomenon that Kamen discovered is known as the blocking effect. Okay, we call it the blocking effect. So the rats in this experimental group did not learn that the light signaled shock because they already knew that the tone signaled shock. So since they only ever saw the light in combination with the tone, their previous association of the tone with the shock blocked their ability to form any association between the light and the shock. So the light didn't give them any new information. In other words, they could already predict the shock based on the tone, so the predictive value of the tone blocked any sort of predictive value that they could have attributed to the light. The light didn't tell them anything they didn't already know, so they didn't learn anything about it. Now, if these rats had gotten a stronger shock when the tone plus light compound was presented compared to when the tone was presented all by itself, then the animals would have learned something about the light. Then they would have acquired a conditioned response to the light because the light would have given them information about what's coming next that the tone by itself didn't give them. But as it was, the same intensity of shock was presented regardless of whether it followed the tone all by itself or the tone plus light compound. And so again, since they already had a conditioned response to the tone, that blocked their ability to acquire a conditioned response to the light. So that's how the blocking effect works. Now, here's a more human, more real life example of the blocking effect. Let's say that every time you go to your grandmother's house, she serves you bread pudding, okay? And let's also say that you hate bread pudding because every time you eat it, you get sick. There's just something about bread pudding that upsets your stomach. But being the polite grandchild that you are and not wanting to hurt your dear grandmother's feelings, you still eat the stuff. Well, obviously, you're going to acquire an aversion to the taste and the smell of bread pudding, right? It's classical conditioning. But then one day, you visit your grandmother over the holidays, and she's decided to shake things up for the occasion by serving her bread pudding with a special sauce on it. Once again, you eat the pudding with the sauce, and as usual, you get sick a few hours later. Guys, where the blocking effect comes in here is that you probably won't develop an aversion to the sauce. So you already know that bread pudding disagrees with you, so you'll probably attribute your sickness to it rather than to the sauce. In other words, your previous association of bread pudding with sickness will block any association that you might have formed between this new sauce and sickness. So grandma could serve that same sauce on a pie or on a brownie or whatever, and you'd probably be able to tolerate it just fine. You wouldn't have that conditioned response of nausea to it. Okay, well, before we move on from the blocking effect, let me just make sure that you guys recognize the difference between it and the overshadowing effect that I talked about earlier. They're both similar phenomena in that they both involve one stimulus interfering with the ability of another stimulus to elicit a conditioned response, but the difference has to do with why that interference occurs. In overshadowing, it's caused by characteristics of the stimuli themselves. So, for example, one component of a compound stimulus can overshadow the other one if it's more intense than that other component. So that was the case in the example I described earlier, where a bright light overshadowed a faint noise, meaning that the animals acquired a conditioned response to the more intense light, but not to the less intense noise. So that's overshadowing. In blocking, we get a similar sort of effect. We still get a conditioned response to one stimulus and not to another stimulus. But in this case, it's not due to differences in the intensities of the two stimuli. Rather, it's because of differences in the animal's prior experience with those stimuli. So, blocking occurs because one part of a compound stimulus has already been associated with the unconditioned stimulus. So, that pre existing association blocks any association that the animal might otherwise have formed between the other part of the compound stimulus and the unconditioned stimulus. Okay? So, same kind of result, but for different reasons, which is why we make a distinction between overshadowing and the blocking effect. Okay. Well, finally, as one last way that previous experience can affect later conditioning, I'm going to finish up this video lecture by talking about a phenomenon called sensory preconditioning. And basically, guys, studies demonstrating this phenomenon can be broken down into three phases. In the first phase, what you do is you take two neutral stimuli and you pair them up. So, for example, if your research subject is a dog, then you might present that dog with a ticking metronome followed by a light. Again, since both of these stimuli are initially neutral for the dog, there isn't going to be an observable conditioned response being acquired during this first phase. This is the sensory preconditioning phase. I should also point out, by the way, since I just talked about latent inhibition, that you want to present a relatively small number of pairings during this first phase to prevent that CS pre-exposure effect from interfering with any later conditioning. So anyway, that's the first phase. Just present a few pairings of these neutral stimuli. Then, in the second phase, one of those stimuli gets paired with an unconditioned stimulus so that it comes to elicit a conditioned response. So, for example, we might take that light from the first phase and start pairing it up with food so that this dog acquires salivation as a conditioned response to the light. And then finally, in the third phase, the other stimulus from phase one, the metronome in this case, is presented all by itself and the animal's behavior is observed. And guys, sensory preconditioning is said to have occurred if the dog salivates in response to the metronome, which it typically does. So even though that metronome had never been paired up directly with food, it still elicits salivation during this final phase here due to the previous association that it formed between the metronome and the light, which has since become associated with food. So, sensory preconditioning represents another way in which an animal's previous experiences can affect classical conditioning. If the stimulus that you're using as your neutral stimulus is one that the animal already associates with something that has since become a CS, then that neutral stimulus may become non neutral more quickly than it otherwise would have. Okay, well, to finish things off here, how about a real life example of sensory preconditioning in humans? I gave you one of those for latent inhibition and for the blocking effect, so I might as well do the same thing here for sensory preconditioning. So, for this example, let's say that you often encounter two flavors together, like cinnamon and vanilla, without any ill effects. So, for example, maybe you like to sprinkle a little cinnamon on your vanilla ice cream. Maybe you like to put a little cinnamon flavored creamer in your vanilla flavored coffee. I don't know. One way or another, you've paired up cinnamon and vanilla in the past. And then one day, you acquire an aversion to the taste of cinnamon. Let's say maybe you eat something that's cinnamon flavored and you get food poisoning from it. And as we'll talk about in the coming weeks, conditioned taste aversions like those can be acquired very quickly, often after just a single pairing of a taste with illness. So you acquire this aversion to cinnamon, right? Well, unfortunately for you, the research on sensory preconditioning suggests that your new aversion to cinnamon would also lead you to want to avoid vanilla flavored things too, because of the previous association that you had formed between cinnamon and vanilla. Just like the dog salivating to the metronome because of its association between the metronome and a light and between the light and food, you might learn to avoid vanilla because of your associations between vanilla and cinnamon and between cinnamon and nausea. Now, an important thing to notice here is that the difference between sensory preconditioning and blocking lies in the order of the experiences. Okay. So in this example, you paired cinnamon and vanilla first, and then you acquired the aversion to cinnamon. So your cinnamon aversion should also result, because of sensory preconditioning, in a vanilla aversion. Blocking would occur if you first acquired the aversion to cinnamon, then had something that was both cinnamon and vanilla flavored, and then got sick. So, in that case, because of the reversed order of the experiences, blocking would occur, meaning that you wouldn't acquire an aversion to vanilla. In other words, your previous association of cinnamon with nausea would tend to block any association from forming between vanilla and nausea. But in the sensory preconditioning example, you already had the cinnamon and vanilla association when you developed the aversion to cinnamon, which is why I'd expect your cinnamon aversion to also produce an aversion to vanilla. Okay, well, that does it for the video lectures for this week. I hope all this stuff makes sense, but if it doesn't, then you know what to do. Send me an email, drop by the Zoom room during my virtual office hours, and I'll try to get things cleared up for you. All right, take care, guys.